Hello students, welcome to the Chemical Analysis and Nanochemistry Research Lab. This is Dr. Kennedy and I'm the lab director for the Chemistry Research Lab. In this lab, the two primary courses taught here are Introduction to Organic Chemistry with Instrumental Analysis and the Chemical Analysis and Nanochemistry Research Lab. So my goal today with this video is to show you the lab and highlight some of the equipment and some of the things that can be done here. And then later I'll have a separate presentation to talk about the course itself, the prerequisites, and some of the topics in the courses. In the lab we have a variety of equipment related to chemical analysis that can be used in the organic chemistry lab for determining molecular structure and studying reactions. A primary tool in a standard high-level chemistry lab such as this one is what's called a gas chromatograph mass spectrometer. With this you can determine molecular structure of unknown compounds or analyze mixtures and determine molecular structure of unknown compounds. Also in the lab we have a 3D printer and a variety of other lab equipment such as a rotovap for distillation. We have what's called a liquid chromatograph and UV vis spectrometers, many different lab stations for doing lab work and fume hoods for doing more complicated lab work or hazardous lab work. And over here we have a variety of spectroscopy instruments, and commonly spectroscopy uses some form of light or energy to measure properties of molecules. The two things over here are a fluorescent spectrometer that can be used to measure the fluorescent properties of molecules, and then we have what's called a UV vis spectrometer. So with that you can measure the ability for a molecule to absorb ultraviolet radiation or visible light radiation. So those most commonly are used to do quantitative analysis. Then over here we have what's called a Fourier transform infrared spectrometer, and what this can be used for is to determine functional groups of molecules. And how it basically performs is, as you pass IR radiation through a sample, some of that radiation is going to be absorbed by the different types of bonds within a molecule. A simple example would be an alcohol would be a higher energy bond than a carbonyl, and they would have peaks in different locations, and based on those peaks or the absence of those peaks, it gives you an introductory idea as to what kind of molecule might be in your sample. In the rest of the video I'll talk more specifically about the courses, the prerequisites, and why the courses would be beneficial to take as a junior or a sophomore or a freshman or even a senior if you're considering looking ahead to senior research. In this portion of the presentation, I'm going to talk more about the courses and the details for the courses, the types of things you'll cover in the courses, and why I think it's a valuable course and program to consider for your course selection process. I'll have a copy of this PowerPoint and the video and some other materials posted within the Organic Chemistry Curriculum Fair Google Classroom. So if you want to go there and see this again or get more materials, please go there after this session or sometime later. The TJ Chemistry program offers 4 different classes. You can take honors chemistry in the summer after 9th grade or just during the school year during 10th grade. One advantage to doing it in the summer is it opens up another opportunity for an elective course, and many or most students continue with AP chemistry in 10th grade after summer school chemistry. You can also do AP chemistry in 11th grade or 12th grade. And then next in the sequence would be the Introduction to Organic Chemistry class that I'm going to talk about more today. The prerequisite for the organic chemistry class is AP chemistry. Then you can also consider for senior year taking chemical analysis and nanochemistry research. The only prerequisite for that lab is just TJ Chemistry 1. So technically, all students can take the chemical analysis research lab during senior year. So like I said before, in the chemical analysis lab, the two primary courses are Introduction to Organic Chemistry with Instrumental Analysis and the Chemical Analysis and Nanochemistry Research Program. I'll talk more about the organic class today and just a little bit about the chemical analysis lab. Overall, both these courses have been very valuable for students who have considered going into areas related to chemistry or physical sciences, and of course in areas related to medicine or engineering disciplines, or even I've had plenty of students continue with these courses because they were curious more about science and wanted to explore problem-solving based learning as a way to help them prepare for maybe being a lawyer or a finance type person. So the courses themselves have direct advantages for students who have a science interest in the future, but also for people who are just purely curious more about chemistry or learning how to solve problems in a unique setting. The primary focus for today was to talk about the lab as a whole, but then also to highlight the organic chemistry class. In general, we cover a variety of topics related to organic chemistry that are at the AP chemistry level, but are instead a focus on organic chemistry molecules and the reactions of organic chemistry molecules. And a great deal of time is put into learning about what's called the spectroscopy for molecular structure determination. So a primary end goal for this class would be to be able to figure out the structure of any organic molecule given the data from what's called an infrared spectrometer and a mass spectrometer and nuclear magnetic resonance spectroscopy. And we also learn about the instruments that are in the chemical analysis lab. In the lab, we'll do a variety of different labs that focus on how to determine physical properties, how to do organic synthesis and characterization of molecules, and also doing UV vis spectroscopy to determine the purity of certain types of chemicals or drugs. So one example there could be determining the purity of aspirin that you make in the lab. So here's just a couple of quick examples of instrument diagrams for what's called FTIR, GCMS, and NMR, the tools that are used to determine molecular structure. Overall, the infrared spectrometer, like I explained before, uses infrared light to measure the properties of molecules and the bonds within molecules. The NMR spectrometer allows you to create a hydrogen map of protons within a molecule, and from that you can use the layout of hydrogen atoms within a molecule to figure out the structure of the molecule. In the bottom right is the gas chromatograph mass spectrometer. So in that case, what you can use it for at the most simple level would be to determine the molecular mass of a compound. At a more complex level, you can figure out the structure of the molecule from what's called the mass spectrum. So as I pointed out in the lab video, we do have a variety of equipment in the chemistry research lab. Most of that is used by students in their research projects. Overall, the lab is, oftentimes students come back and comment on how the lab is more equipped or better equipped than a lot of the small college labs they've been to outside of TJ. So overall, we probably have about $500,000 of advanced chemical instrumentation. Most of this, again, is available for students in the research lab, but we will learn about them within the organic chemistry elective class. Here's just a couple quick examples of some common chemical analysis research projects, if it helps you to have a little bit of a foresight for what kinds of things you could do in the chemistry lab. So some examples, many examples build upon interest in nanotechnology, applications of nanotechnology. We have many projects dealing with environmental analysis, environmental remediation, and of course projects that are dealing with complex chemical synthesis or applications of chemistry to more unique settings. So students have done things in the past where they've integrated nanotechnology with creating chemical nanosensors for use in the environment or potential use in natural settings or biological settings. And I know today is not a long session, so I wanted to make sure I save time for questions. So after the video, there'll be plenty of time for questions. Thank you for coming.